So what we're going to do today, we're just going to get started on trigonometry. Now we're first going to start with Pythagoras, just a review of Pythagoras, because what you'll find is that trigonometry is relatively similar to Pythagoras, except that it is lets us do a lot more than Pythagoras does, okay? And it's also, there's a lot more to understand in trigonometry than Pythagoras. But let's do a quick reminder of Pythagoras. Now, I'm only going to go over it like very, very, very briefly. If you guys don't remember Pythagoras' theorem, please make sure that you do go back to our year 8 notes and review Pythagoras, because it's super important to make sure that you guys are like 100% with Pythagoras, okay? So let's get started. So Pythagoras is a technique, or I might say is a theorem.
Pythagoras theorem.
Yep. Which we learned last year in year 8. Okay? Right? That helps us find that, or I might say that allows us to find missing lengths
Pythagoras.
on a right-angled triangle. With Pythagoras, we didn't need...
Why do they call it a theorem?
Because it's a theorem. It's like a mathematical theorem.
What's a theorem?
Like a set of equations that governs the way something works.
Oh, yeah?
So guys, just a reminder, you don't have to write everything down, just take notes. So obviously you don't need to write Pythagoras is a theorem, which we learned last year in year 8. These are just for you. Like, I write these notes because I want you guys to be able to read over them in the future and still understand them. But you guys just need to take like dot points, okay? So with Pythagoras, we didn't need, for example, we didn't need any angles in the triangle. And we also didn't need and we also did need two sides. So we could only find one missing side if we had, so we could only find one missing side if we have the other two sides. Does that make sense, guys?
Yep. A little bit.
I'll draw a diagram so it does make sense. So it must be a right angle triangle. We remember that this is the hypotenuse, yeah? Which is always C in the theorem. And then these are the shorter sides.
Oh, yeah. No, I got it. So it's kind of like ABC. Like
Yeah,
that.
exactly. These are the shorter sides. And what you guys need to understand is that with Pythagoras' theorem, we can only solve for one missing side, which means we need the other two missing sides. No, we can solve for any. So we can either solve for this side, or this side. But if we're solving for this side, that means we have to know these two sides. If we're solving for this side, that means we have to know these two sides. Does that kind of make sense?
Yeah.
So the theorem states c squared equals a squared plus b squared. Okay? And so to solve the Pythagoras' theorem, you should be able to just plug in numbers and rearrange using our algebra skills. Does that make sense?
Sure.
Yep. Let's do a few quick examples just to make sure everybody remembers how this works. So,
Up a tiny bit, please.
yeah, sorry.
Thank you. Not all the way. You can just go up to the second paragraph.
No, it's alright. I'll just leave it like that. Can we please try these questions?
How do you write straight?
What?
How do you write straight?
He has lines on his book.
No, like how does he write like with his book straight?
Oh, I get you.
If I write like this, it will make me like write diagonally on the page.
Oh my god.
Unless I like turn my body.
Alright, can everybody please try those for me?
You know, yesterday I saw a girl scratch her ass at the wedding.
Ew.
Like her full on hand was
Stop
inside
it.
her
Stop.
pants.
Stop. Stop it. Stop.
What?
I was just walking past.
Stop. Do the question. Stop talking. Do the question. So for Ava on the recording, you should also try the question as well, please.
Hey, Ava.
So yeah, just make sure everybody tries the question. Ava, for you, please don't skip ahead and get the answer. Actually try the question first.
Cover 2 sides. Skyscraper. Ew, this is like physics.
No, it's not. Alright, so I'll give you guys a hint. You guys want to draw a right angle triangle right here.
Okay. The bottom is 25.
Yep. We also know that the height of this building is 80. And the height of this building is 50. So you guys should be able to work everything out from there.
I was trying to find the cable.
Yep, you're trying to find the cable. That's exactly right.
Sorry, guys.
No, it's fine.
Just looking for my DVD, I forgot. Why do we need to know the 50-meter thingy?
Because you need to know, remember, you need to know two heights. So you know this height, you know this length, but you don't know this length. You need to find it. How are you going to find it?
50 minus
80
80. Sorry,
minus
50.
Let's have a look. Good job, Chris.
That's it, already.
I taught him Pythagoras when we were one-on-one. It used to be just me and Chris. And I taught him Pythagoras and we spent a really long time on it and he got really, really good at it. So good job. I'm happy that you still remember.
What was the thing again for this length for A? How do you find that?
That's
So remember, that's the hypotenuse. The hypotenuse is always which letter?
C.
Yeah, so it should be c squared equals a squared plus b squared.
Oh yeah, I thought it was a minus 1.
So c squared, c squared
Sorry.
equals a squared plus b squared. Actually, Chris, show me. One thing I didn't check. Yeah, but you need to find c, not c squared. So you found c squared. Find c for me as well, because the whole point is that you're supposed to find the length of c. Do you remember how to do that? You square root. Remember, Pythagoras always has the square roots. Remember. So make sure you find c by doing square root of 1,200 and whatever you got.
Sorry, what?
It doesn't matter. It doesn't matter. Just you do what you want to do.
I remember.
No, Annabella, what are you doing?
What?
Show me your book.
I added them.
No. What are you doing?
I found that.
Okay, so can we draw the diagram properly? So we put a 30 meters here, and then we end up with c squared equals 30 squared plus 25 squared, because c squared equals a squared plus b squared. So you didn't square them. So you can't just add those. So this is wrong.
Okay.
I squared rooted it.
Beautiful.
1,500.
Yes, brilliant. Okay, so I'm going to start writing the answer down. Ava, I hope you're done by now too. So to find the answer, we've got that little triangle in there. We know that the height of the triangle is 30 meters, the width is 25 meters, and we know that the cable is c squared because it's the hypotenuse. So 25 squared plus 30 squared. And then when I plug that into my calculator, I get 1525 meters. Is that correct?
Yep.
And then to find c is the square root of 1525. So that gives me 39.05 meters. Everybody okay with that? Yep. Beautiful. So I hope everyone remembers how to do Pythagoras. Now we're going to do slightly harder Pythagoras, which is Pythagoras in 3D. Okay? So Pythag in 3D. Let's go through this. So the first thing that we are going to want to do is understand what these problems can look like. So let me start by just drawing a prism.
Triangle.
Square pyramid, sorry, is what I meant to say. So I'm just going to start by drawing a square pyramid.
Very nice.
And then
Clear.
so there I have a square pyramid. And then I'm going to draw So can you guys kind of see how I can cut out a right angle triangle from a square pyramid?
Yeah.
So it's a 3D shape, and I can cut out of it a 2D shape, which is the triangle, right? So we can take a cut So we can take a right angle triangle cut out of a 3D shape as shown below. In doing this, we can now perform Pythagoras on 3D problems as well. Does that make sense? So let's do an example. Now, I'm just going to be very, very clear, guys. these kinds of questions are going to require a lot of visualizing, okay? So you guys are going to have to try to visualize what's happening in your head, because it is really confusing if you're only looking at the shapes that are given to you in the question. You have to try to visualize what this would look like in 3D. All right?
Can you scroll up the tiny bit for like 1 second? Thank you.
So just write down some notes on this, and then we will get started with this question, please. So Ava, again, please try this question. So, what I want you guys to understand, remember, visualize the shape. It's asking you to find the length of AC, yeah?
Yeah.
So the first question I'm going to ask you, maybe I'll get Chris to answer this. Chris, do I know, so if I look at this triangle that they've drawn for me, do I know the two other sides of the triangle? Do I know that length and this length?
You know that length, but not the...
Exactly, you don't know that length. So you should immediately know that you can't perform Pythagoras on that triangle that they've drawn because you only know one of the lengths. We can't do Pythagoras on that length.
Yeah.
Instead, what we can do is we can use this triangle, can't we?
Yeah.
So, if I draw that triangle instead, whoops. Sorry, I don't know why it's drawing it like that. Okay, so that triangle I can use because that is a right angle. Even though it doesn't look like a right angle, okay, you guys, this is what I said about you need to visualize because
From like a front point of view, it's...
Exactly. From the top point of view, it is a right angle, but because you're viewing it from the front point of view, it looks stretched, but it's not. Okay? So I can redraw that red triangle. And in this topic, guys, Pythagoras in 3D, I highly, highly recommend that you guys are using colors, like different colors, because it's very helpful to visualize things with different colors. So first, find AC. So that's for part A. And then for part B, we've got that. So does everybody kind of understand how to do these 3D problems a little bit?
Yeah.
Yeah.
I square rooted the c squared, but they want us to find it in exact.
Yep, so remember, exact just means simplify the surd. You guys should remember how to simplify surds, I hope.
No.
So remember, guys, I told you if we do go ahead in the content, you have to make sure that you guys are remembering how to do everything I teach you. So that means constant practice. So What did you? Can someone tell me what did you get as exact value for AC?
Not done yet.
Chris, what did you get?
I got 13. I'm not sure.
No. So, it might be 13. No, it's not 13. What did you get as the exact value? So in the square root.
14.42.
No. In the square root, the exact value. Remember, exact value.
208.
Yeah, remember exact values as part of the square root. So we get AC equals 208, and I hope that everyone knows how we got there. Now, remember, simplifying surds. Guys, again, you will be getting tested on this at school. I have already taught it to you, though. So please make sure that we are, like, remembering how to do this stuff, but I will go over it again. So simplifying surds is essentially just understanding a few really important things. And the first really important thing that you have to understand is that inside of a surd, there is a number. Let's say it's AC, or let's just say AB. I can rewrite this as A times B. Yeah? Can everyone kind of see that? I can write square root of AB as square root of A times square root of B. Everyone agrees with that?
Yeah.
So what I can do is so remember, you type 208 into your calculator and you click shift fact, and it gives you 2 to the power of 4, so 208 equals 2 to the power of 4 times 13. Yeah?
Sure.
Right? So I can rewrite the fraction as, let me change the color. So I can say 208 equals 2 to the power of 4 times 13, right? So then I can say AC equals 2 to the power of 4 square rooted times the square root of 13. Can someone tell me what is the square root of 2 to the power of 4? And then I just write the root 13. And can I simplify 13? No, because it's a prime number. So that's how we simplify surds. Please make sure that we do understand how to simplify surds, guys. Once you guys have done question A, please move on to part B as well.
AD. Oh, D.
Everyone finished?
Really?
All done, guys? Or
Yeah.
Hold on.
yep. Okay. I'm gonna start going through it. So we know that we can swap AC for the value that we found, which is 4 root 13. Yeah. And so we can say that AD is still the hypotenuse, so it's going to be AD squared equals 4 squares plus 4 squared root 13 squared, which gives us AD equals 16 plus 16 times 13, which is 208. And then we get, AD squared, and then we get AD equals the square root of 224. And it says correct to 1 decimal place, so the answer will be,
My hair.
and so the answer will be 14.97.
Wait, is it not 1 decimal place?
Yes, it is. So it should be 15.0 centimeters. Does that make sense to everybody?
Yeah.
I hope no one's too confused about that. Pythagoras in 3D can sometimes be a little bit hard to wrap your head around. So if you are at all confused, please make sure that you do the homework, because I will be sending through some homework for that.
Yep.
Okay? Alrighty, let's go on with
No.
what?
The thingy. We have to do that now.
Do what?
Trig.
Yeah, trig. So let's go through trig. Now, I think most students are very confused about trig, mainly because they teach it horribly at school. I'm going to teach you guys trig. Now, what I want you guys to do is understand that what I'm about to teach you is probably one of the most important things I've ever taught you for your senior school math, okay? That means that whatever I teach you here today, you're going to be able to directly use this stuff that I'm teaching you right now in year 11 and 12. Please make sure that you understand. I'm not going to be going through any of the textbook stuff today. Today, I'm just going to be helping you guys understand what is trigonometry, okay? Because nobody understands what trigonometry is. I'm going to explain what trigonometry is. I'm going to explain what all those sine, tan, cos functions are. Once you guys understand those, then this topic is going to be really, really easy, okay? So let's get started on what is trigonometry.
I don't like the name already.
Again, this will be a learning curve for you all, but I want you guys to just take it slow and kind of just try to understand what's going on. All right, so trigonometry is the study of circles. It allows us to understand a very important circle called the unit circle. And find its features on the Cartesian plane. let me draw a Cartesian plane and draw the unit circle. Now, there is a reason that this circle, now, I don't think any of you guys have ever heard of the unit circle before, but there is a reason that this circle is really important. And it's because it is the circle that is exactly in the middle with radius 1. So all of its coordinates will be 1, 1, -1, and -1. Okay, so it's got a radius of 1, okay, diameter of 2, and it's centered right at the middle of the Cartesian plane. Does everyone understand that? Yeah?
Yeah.
You guys are going to become best friends with the unit circle in this topic because it's so, so important to understanding trigonometry. Okay? So let's kind of start to understand, if I pick a random point on this circle, let's say I choose this point right here. Everybody kind of understands that this point will have a few things. I'm going to draw a few really important parts of this point. It's going to have a gradient, which I am putting in green, okay? It's going to have an x-coordinate, which I'm putting in, let's say I put it in orange. And it's going to have a y-coordinate, which I'm going to put in blue. Okay? So it has an x-coordinate, a y-coordinate, and a gradient. Yeah? Does everybody kind of understand this?
Not really.
I'll explain it. One sec. Thank you for saying not really. Okay, so let me explain, guys. All I've done is I've picked a random point on the unit circle. So a point that lies on the unit circle. Yep. And then we have the y-coordinate of that point. Yeah? So the y-coordinate will be how high it is on the y-axis. Yeah? The x-coordinate of that point, right? So this is the x-coordinate, the y-coordinate, and also the gradient. So basically, how steep is that point from the middle of the circle? Yeah? Does everybody kind of understand?
Okay.
Makes more sense now?
A little bit, yeah.
So, I know that no matter which point I pick on the unit circle, the triangle that I draw from the x-coordinate, the y-coordinate, and the gradient is going to be a right angle triangle. So let's test that theory. Let's try another random point. Annabella, do you want to just draw a random point for me on the unit circle? Pick a random point and just draw the point. Doesn't matter where it is. No, on the unit circle. So it has to be on the line. Yeah, because that's not in the unit circle, is it? It's not on the unit circle. It has to be on the unit circle. Beautiful. So Annabella's just picked a random point on the unit circle. Chris, can I get you, please, to draw a few things for me? I'm going to get you to draw, one second. So I've got the green over here. I've got the green, yellow, and blue for you there. Can you please draw a line that shows the x-coordinate, a line that shows the y-coordinate, and a line that shows the gradient to that point, please? So if you, just so I can quickly teach you how to use the iPad, if you draw and hold it, it'll like straighten the line. So just do that. So the gradient will be in green, so draw the gradient first. So remember what a gradient is, guys? Yep, beautiful, Chris. Can you now draw the y, so just pick that color, and draw the y coordinate for me. No, so you just drawn the x coordinate. So be really, really careful. Can I just show you quickly? So where's the laser pointer? Why can't I do it upside down? Okay. So remember, the y coordinate will be how far is it from here to there. Yeah?
Oh.
That's the y coordinate. Does that kind of make sense? Just think of it like a normal point. If you thought of this point, the point to tell me what that point is, you would go x then y, wouldn't you?
Yeah.
Yeah? So draw the y bit, or actually start with the x bit. I think that makes more sense. So start with the x part first. So draw the x of that point for me.
So here.
Well, of the point. Don't worry about the other point that I drew. So yeah, that looks roughly right. Beautiful. And then can you use the blue And can you draw the y for me? Beautiful. And do you guys see how, again, we have a right angle triangle, right? So what you guys are going to find is that if we go on every point around the unit circle and we draw in the x, the y, and the gradient, we always end up with a right angle triangle. And that's why at school they tell you, oh yeah, trigonometry is the study of triangles. No, it's not, okay? So don't get confused about that. Trigonometry does not study triangles. Trigonometry studies circles. And as a result of studying circles, we also come in contact with some right angle triangles as well. But realistically, we are actually just studying the unit circle, okay? So does everybody kind of understand? Annabella, pay attention, please.
Sorry.
So does everybody understand what I have spoken about so far?
Yeah.
We have a unit circle, we pick a random point that lies on that unit circle, and we can say what the point of that unit circle is based on that, like, x, y, and gradient.
How does
Yes.
how does the topic circles link to like other stuff? Like
I'm about
triangles?
to show you. So we're about to use this topic of circles to actually help us find the lengths of triangle sides without Pythagoras. So what I want you guys to also realize as well is that we have what I'm going to call an elevation. What I mean by elevation is an angle right here, okay, that tells us the angle from the x-axis to the so positive x-axis to the gradient of the triangle. Yeah, everyone can kind of see that. I'm going to use a different angle there because it's not necessarily equal. So I'll use alpha and theta. Does everyone kind of get that?
Yeah.
What I'm going to do so I don't confuse you, I'm going to delete Chris's one, but I'm sorry, Chris, but I just wanted to make sure that you guys understood. But now that we understand, so we also know there's a theta, yeah?
Yeah.
Here is my claim to you. Are you ready? To find these lengths, right? Because we understand that this x coordinate is just a length. Because it starts at 0, if I find this x coordinate is 5, for example, it's obviously never going to be 5 because the unit circle is maximum of 1. But let's just say it was 5. Does everyone understand that this length would be 5, right?
Yeah.
So because the trigonometric identities use only the unit circle, we don't use any circle but the unit circle, which means it's a circle of just 1, okay? That means that if I find the x coordinate, I've also found the length of that side of the triangle, yeah? So here's what I'm going to tell you. Cos is x, sine is y, so y is sine, cos is x, okay, and the gradient is tan. All right? Now, it looks confusing right now, but we'll go through a lot of understanding things to make sure that you guys get this. But this is the gradient, and that's m. Does everyone remember that the gradient is m? The gradient of a line is y equals mx plus b, and m is the gradient, yeah? Everyone remembers that? Okay. So let's make sure that we have a proper understanding of what the hell I mean when I'm talking about this. So let's go to Desmos, our best friend. Is everyone done?
Yep.
Yep, okay. Let's go to Desmos. All right, we're here at Desmos. I'm going to draw the unit circle for us. So x squared plus y squared equals 1. Here's our little unit circle. Yeah. Everyone can see our unit circle. That's our unit circle. Yeah. And here's what I'm going to do. I'm going to draw a random point on that unit circle. Let's say I pick this point right here. Actually, I'm going to draw y equals x. And we're going to pick this point right here. Yeah? Yep, so we're going to try and figure out what are those points. So let's take a screenshot of this. Do we already know tan theta of this point? So remember, I said tan theta is equal to m, right?
Yep.
Hold on, let me also just do something here. 1 second. Where x is greater than 0. All right, there we go. And
The shoes are such a vibe.
Point. Thank you. Okay, so I've just drawn that, and I'll not looking like much of a circle anymore. Okay, there we go. All right, so can everyone kind of see how I've drawn this line? Yeah? I want to figure out what is that point. Yeah? Do we already know M? Can someone answer that for me? Remember, M is the gradient. No, hold on. Let's try and fundamentally understand this. So M is the gradient. Remember, M is tan theta. Yeah, and what is theta in this case? Can someone tell me when I draw? Oh, sorry, that was my fault. That was the charger. Sorry about that. I'll just take it. And do you need it to keep charging? I'll just put the charging brick here. Sorry, guys. You can just leave that on the floor. All right, so what we had to understand is, don't worry about the circle for now. I want someone to answer this question for me. If I draw a Cartesian plane and I just draw the normal line y equals x, what is the angle that y equals x makes with the x-axis? So let me just draw what I mean so that you guys can kind of see what I'm talking about. Okay. Let me get this line, y equals x, right? So I just draw my Cartesian plane and I draw the very basic line y equals x. Can someone tell me what is that angle? You guys should know this.
Cos.
No. Don't worry about sine, cos, and tan. Ignore trigonometry. What is that angle?
Alright, so
45.
acute.
Huh? 45. Beautiful. Why is it 45? Can someone tell me?
It's half of 90.
Exactly, because it's half of 90. Yeah? So we're taking the right angle, so this part right here, and we're cutting it directly in the center. That means this is 45 degrees. Yeah? So we already know what the angle theta is. Does everybody kind of get that? We know that theta is 45 degrees. So I'm going to swap theta for 45 degrees. Yeah? Yeah? Now, tan 45, what do we expect it to be equal to? What is the gradient of this line? Everyone should know this already. Don't be confused by the trigonometry. Look at this line that I just drew. What is the gradient of this line? Guys? Okay, thank you. But what is it equal to? So, a reminder, this line is y equals x. The general form of a line is y equals mx plus b. What is m in this line?
45.
No. Stop guessing.
X.
No. Y equals mx plus b. Is there a b in this equation?
No.
What is the m?
The Y.
Chris, what's the m? What is the number in front of the x?
Is it 1?
Yes. So guys, review your lines, please. We've already learnt about lines last year. I can't reteach you everything I've already taught you. So maybe it would be good use of your time to make sure that we understand our lines, because you're going to need lines. Okay?
Daddy on the table.
That's disgusting. I really need to actually sand this table and remove everything that people write. So when I told you guys that I expect the gradient of, so we're trying to find this point, so let's not lose sight of our goal here. Our goal is to find out the x and y coordinate of this point. Yeah? That's our goal. We want to figure out the x and y coordinate. So, Chris, can you tell me what should tan 45 be equal to? When I told you tan 45 is always, don't worry about tan 45, but I told you that tan of any point should always be the gradient from the origin to that point. So what should it be?
1.
1. Thank you. Now, can everyone plug in tan 45 into your calculators and double check that it should be equal to 1?
I already did. I did
What the
before.
front door?
What?
Have you already typed it?
Get your calculator. Plug in tan of 45. Yep.
Sin, cos here, 10. 10 with...
Why did you do shift? Hold on. You just did tan inverse. No. Dude, just click tan. Tan of 45. 1. Right? So, Does everybody understand why tan of 45 is 1?
Yeah.
Yep. Because when we get from our unit circle, we get a line that is 45 degrees elevated. That line has a gradient of 1. And we know that trigonometry says that tan is always the gradient. Does everyone understand?
Yeah.
Beautiful. Now, let's see if we can figure out what this is equal to. What is this x coordinate equal to? Chris, which of the trigonometric functions gives us the value of the x coordinate?
Cos.
Exactly. Cos 45, right?
Yeah.
So, Chris, can you please plug that into your calculator and tell me what should the x coordinate be? Just give it rounded to like 3 decimal places. So, Tommy?
0.707.
Beautiful. And Annabella, what is the y coordinate going to be?
Sin.
Yep, so sin of, it's sine, sorry, not sin.
45.
Sine 45, beautiful. Can you plug that in and tell me what it's equal to?
0.70.
707, right?
Yep.
So, can I get, Chris, can you tell me what is the coordinate that this point should read when I click it? It should be x and y. So what's the coordinate?
It would be 0.707 and 0.707.
Right, that's what we expect, yeah?
Yeah.
Now let me just copy this. I'll put this in our notes. As an example. Now, let's go back to the Desmos and let's check. So let me just turn this off. All right, and so we expect that when I click that intersecting point, it should be 0.707, 0.707, and it is. Can everyone see that?
Yeah.
Yep.
What about the 1 at the end?
Yeah, so when you plugged it into your calculator,
You had a 1.
Oh, okay.
yeah. So what you guys kind of need to understand is that the trigonometric functions won't always give you an exact answer because there are surds involved, but we won't talk about how surds are involved. But the trigonometric values will not always give you an exact answer, so usually we'll have to round them. All right? Does everybody understand what trigonometry is? I'm going to get someone to explain it back to me, and that person is going to be Annabella.
Off of
Go ahead.
trigonometry is the how do you say it, of circles? Not the value.
So I just want you to I want you to just give me an overview of what we just learned. So just tell me what we just learned.
Sin, tan, cos.
Yep, and so what is sin, what is tan, what is cos?
Sin is like the y side
Of what?
of the right angle triangle. Not always the right angle. But
No,
like
it is always a right
a
angle.
right angle triangle.
But what is the right angle triangle? Where does that triangle come from?
The circle, the Cartesian
Yeah.
plane.
Yeah, exactly. So basically what I want to hear is the trigonometric functions tell us the x, excuse me,
Bless you.
the trigonometric functions
Okay.
take a random line with some type of theta, okay, whatever that theta may be.
From the circle.
They take the theta from the x value, okay, from the positive x coordinate.
Does it always have to be
From the positive x coordinate. So for example, if I was to draw this line, it would be from the positive x coordinate. Does that make sense?
Okay.
Now, that's basically what we want to know.
I have a question.
Yep.
Why wouldn't it land on the negative? Like, why can't we put it on the negative?
Like, as in, why can't we do it from this coordinate?
Yeah, from there, yeah.
Because it is a mathematical convention that when we measure angles,
Okay.
we go anti-clockwise from the positive x coordinate. So you'll learn that when you're in year 11. But when you're in year 11, we start talking about angles measured from the x of the Cartesian plane anti-clockwise. Does that make sense?
Thank you, yeah.
Now, basically what I want to hear when you guys are explaining what is trigonometry. Trigonometry, the trigonometric functions, so tan, cos, and sine, okay? What they tell us is they allow us to find the x-coordinate, the y-coordinate, and the gradient of any point on the unit circle. Does everybody understand that?
Yes.
Okay, so let me write that down. So sine, cos, and tan
The lightsaber.
allow us to find the x, y, and m of any point on the unit circle.
Why are they all the same, like the thingies, the thingamajiggies, the zeros?
Oh, the theta, you mean?
Yeah.
Because of course it'll be the same, because for any line, the angle for that line is always going to be the same, isn't it?
Yeah.
It's like for this example that we did right here, 45.
True.
It's always, you always plug in 45 because that's the angle. Yeah? So let's do some examples of this just to make sure that we 100% understand it.
What was that?
You alright?
Is it? I have another question. Is it specifically always x and y
Yes.
and m?
Yes.
So it can't be a, b, c.
No, because it's the x value, like it's relative to the Cartesian plane. Can the Cartesian plane be ABC?
No.
So, no. Got it?
Got it.
Alright. Now, I'm going to do this example with you guys because there is one thing that can get a little bit confusing. Remember what I said. The angles are always measured from the positive x coordinate, from the positive x axis, right?
Yep.
So that means this angle, let's say this angle is, let's say this angle is 130 degrees, yeah? So theta is 130. Yeah? So here's what I'm going to plug in. Tan 130. Yeah.
Yep.
Do I expect this to give me a positive or a negative value?
Negative.
Should be negative, exactly, because the gradient is negative. So tan 130 gives me m. So m equals tan 130, which equals negative 1.192. And that's as we expect. Now, x. Can someone tell me what is x going to be equal to?
Cos
Of?
130.
Yep. And should it be negative, positive? Or,
Negative.
yes. And so cos of 130 gives us negative 0.64.
How'd you get there? Are you using a calculator?
Oh, yeah. I'm not doing this in my head. Okay. And then, Chris, can you tell me what the y is?
Sin 130.
Sine.
Sine.
And can somebody tell me, is it
0.
positive? No, hold on. Chris, should it be positive, negative?
Negative.
Why? Have a look at the y. Is the y positive or negative?
Oh, it's positive.
It is positive, so it should be positive, right?
Yeah.
So we get 0.66.
76.
Yeah, beautiful. Okay, now here's the confusing part. Here is the part that you guys have to be very weary about. If I draw this triangle that I just drew, right? Can we all see how this triangle, what's the angle of this triangle is 50 degrees, right?
Yep.
That's the adjacent.
So what you guys have to notice is if I draw a 50-degree triangle here, yeah?
Yep.
Because if I plug in sine 50, it's obviously going to give me this one, right? Because
Yeah.
that's 50 degrees. So sine 50 will give me, cos 50 and sine 50. So sine 50 is going to give me the same value as this triangle, right?
Yeah.
The gradient is going to give me the same value, except it's going to be positive instead of negative.
Yep.
And the x is going to give me the same value, except it's going to be positive instead of negative. Okay, so does everyone want to try that? Plug in sine 50 and tan 50. Sorry, plug in cos 50 and tan 50. And you should get the exact same answers. The only difference should be that it's positive instead of negative. So can everyone try that? Yeah? Exactly. Beautiful. Does everyone understand why?
Yeah.
So now, what am I going to write on the bottom? Can someone tell me what is the length of this triangle? Remember, lengths can't be negative. I'll remind you of that. So if I tell you guys that the length of this is 1, someone tell me what is the length of that triangle?
0.642.
0.642, yep. Or 0.643.
Oh, 643, sorry, because you're rounding it.
Yep. Chris, can you tell me what is the y going to be equal to? You don't need to use your calculator. You can just look at what I have on the board. You don't need a calculator. So it'll just be the y. So what do you think it'll be? It'll just be the y coordinate.
0.766.
Yep. And so the reason that it's just the y coordinate, Chris, in case you're confused about that, is just because we start at 0 and we know that this is 0.766. So obviously the length would just be 0.766.
I actually don't mind this. This is fun.
So does everyone kind of get this?
Yeah.
Yeah. So if I give you a triangle and I tell you that the length of that the hypotenuse is 1, do you guys see how the hypotenuse of any triangle on the unit circle will always be what?
1.
1. So if I give you a triangle and I give you the angle, you can always figure out the x and y. Yeah?
Yeah.
So for homework,
I still don't get how tan is hard. Like annoying to you.
it's annoying. I never said it's hard. It's just annoying because like I just don't enjoy dealing with gradients. They're just kind of lame, you know? So for homework, guys, find the length, find the missing length of the following triangles. Alrighty. And I will write that as a quick reminder. So let me just write down reminder. Every single triangle on the unit circle will have a hypotenuse length of 1. Alrighty?
Yep.
So let's go ahead and give you some questions and we'll call it a day.
Oh, I thought we were going to put it on Discord.
No, I'll write them here and then I'll screenshot and put them on Discord.
Okay. I think someone's here.
Miana,
Yep.
what time do you finish?
Right now.
Okay.
Fair enough.
She's so cute.
20 degrees. Let's do... So guys, remember, find the hypotenuse. I'm telling you that the hypotenuse value is 1. Yeah?
Yeah.
And just remember, take the triangle and position it in the unit circle because it'll help you a lot. Okay? So make sure that we position it in the unit circle. To answer these questions, you will have to position the triangles in the unit circle. That is the last time I will say that. Okay?
Yep.
And then finally, I'll just give you this one. Let's go through one example together. Sorry, I'm going to go slightly over time. We'll go through one example together and then I'll let you guys go. Okay? We'll go through this example because I think this is the one that you guys are probably going to find the hardest. Yeah, okay. Yeah, okay. So let's do this one, right? So we can see the right angle is here. Now remember, to position this in the unit circle, what I'm going to have to do, okay, is I'm going to have to actually rotate it. So can everyone kind of see that? So watch this. Everyone watching? Everyone watching. I'm about to explain. So if I draw my unit circle, right? To fit it in the unit circle, I'm going to have to rotate it. So if I take resize, I'm going to have to rotate it so that the angle is coming out of the origin.
Oh, okay.
Remember, the angle has to come out of the origin. Yeah? From the x value. From the positive x coordinate, the angle has to come out of the origin. Yeah? So that's why I have to rotate it. Now that I've rotated it, right, I can find cos 60, sine 60, plug it into my calculator, and that's my answer. So can everyone do that for me, please?
Cos 0.5 for cos and sin 0.766.
Okay, so if I just draw my triangle how I drew it before, like that.
Yep.
And I have my 60 there, and my 60 is there, and my 1 is there. I have just found the lengths to be, so this one is 0.5. So don't get confused. I know that it's confusing that I put the x with the y here, but the reason for that, and my screen recording just turned off for Ava. That's really annoying.
Is it because you had to turn it?
You have to turn it that
Yeah,
way.
so everyone understand that the reason that I had to actually put okay, so the reason that I had to actually turn it, all right, I hope everyone understands the reason I had to turn it is, sorry, not the reason I had to turn it, the reason that I put the 0.5, which is actually should be the x value, the reason I put it on the y here is because when you turn it to fit in the unit circle, it should be on the x. So then when I turn it back, it looks like it's on the y, but it's actually on the x. Okay? And so this one will be 0.766. And let me just put centimeters in all of them. Okay?
Yeah.
Does everybody kind of get it?
Yeah.
So I'll get you guys for homework to just do those examples. Alrighty? Please do those for homework, and
Do you have to twist them as well?
it depends. You have to figure that out.
Oh,
So
yeah.
that's kind of the hard part of these questions. You have to figure out if you have to twist them.
Yeah, we have to twist them.
Not all of them. Potentially not all of them. But some of them you will have to twist, yes. Okay?
Is it between those two and that's it? Homework? Or is there
Yes. That I'll give you like maybe 2 more just to practice.
more? Thank you, Marianne.
All good, guys. Thank you so much.
It wasn't actually that bad. I thought it would be like really bad. Looking.
Not too bad, no. Trigonometry is really quite easy. We haven't actually gotten up to the year 9 part yet. So the part I've actually just shown you is technically the year 11 part. And then we'll get up to the year 9 part after that. So the reason I've shown you the year 11 part before the year 9 part is because the year 11 part requires you to understand what sine, cos, and tan are actually doing. And so that's why I've given that to you first. Okay? So now that you guys understand what these functions do, next week we'll actually look at how to answer your year 9 questions. All right? And I'll say this one will be 24 degrees. Alrighty. So just do those 4 questions for me. I'll post them on Discord, but also please remember that the notes are available in the notes on Google not Google Classroom, but Google Docs. And also remember, guys, that I have recorded this video for Ava, so I will post the video on the server. If any of you guys need to re-watch it to understand what we went through, because you might forget this stuff, because you never really look at the stuff like this, but it requires this understanding for you to make sure that you don't get any of the questions wrong. But if you guys do forget how to do the homework, you leave it to last minute and you need to re-watch one of the videos, or like you need to re-watch the video to understand what the hell we did, please make sure that you guys do watch that video. It's only about, I think, like an hour and 5 minutes long. So it's not particularly long, and you can just skip through and go to the parts that you struggle with. Alrighty, guys? Alright, bye, Ava.